We're simplifying. So you have 2 to the power of 7 divided by 2 to the power of 4. That's going to be 2 to the power of 7 minus 4, which is obviously 2 to the power of 3. And once again, we do not do 2 times 2 times 2. We just leave it as 2 to the power of 3 because it's asking us to simplify, not simplify and evaluate. Here we have x to the power of 4 minus 3, which is x to the power of 1. That's it. Easy stuff. Let's move on. Here we have the power rule, where we are now multiplying the exponents. So 2 to the power of 3 to the power of 4 is going to be 2 to the power of 3 times 4, which is 2 to the power of 12. X to the power of 5 times 2, x to the power of 10. This is very easy to prove. I'm not sure if anyone explained this to you, but I can't remember even if I did it earlier. Probably not. I was running out of time. But remember, we have exponents. What did exponents mean? It means that you're multiplying that bracket that many times. So if I expand this, that basically means that I'm taking the bracket 2 to the power of 3 and multiplying it by itself 4 times. So 2 to the power of 3, 2 to the power of 3, 2 to the power of 3, 2 to the power of 3. And if you expand this further, you know that, well, we know that for multiplying exponents, we can just add the numbers. So it's going to be 3 plus 3 plus 3 plus 3. But something that you should have learned a really long time ago, that repeated addition is multiplication. That is the definition of multiplication. For example, 5 plus 5 plus 5 is 15, which is also the same thing as 5 times 3. So you can see that multiplication and addition are related in that. All right, let's move on to the next example now. Here we have, the easiest rule from my experience. The anything to the power of 0 rule. If I have 2 to the power of 0, guess what? The answer is 1. X to the power of 0, guess what? The answer is 1. That's the easy one. And here we have, I would say, the most difficult one. The negative exponent rule. So, negative exponent rule. Whenever you have a negative exponent, see that base number, turn it into a fraction if it's not already a fraction. So any number that's not a fraction, just make it over 1. Why does it help you? 2 over 1. And then we flip that fraction. So it becomes 1 over 2. And then the exponent follows the base number. So it stays with the 2. So this is going to be 1 over 2 cubed. That's the answer. And then here we have 1 over x to the power of 6. That's it. All right, exponential relations. What does that mean? Well, we have an equation, y equals 2 to the power of x. The graph that looks like this, or a table that looks like this. In this table, the way to figure out whether it's an exponential relation is to not use first differences or second differences, but to kind of realize you are kind of doing first differences, but what you're doing is you're seeing to see not if they're adding or subtracting, going up or down by a constant number, but if they're multiplying by a certain number. So what do I mean by that? Well, look at my y values. And you see how 1 to 2 is times 2, and then 2 times 2 is 4. If you keep going the same way, 0.5 times 2 is 1, and 0.25 times 2 is 0.5. So the multiplication factor is the same. So the ratio is constant. That's what you say. The ratio is constant. And that basically just means the multiplication factor. Here we have some characteristics. We're increasing the base. Sorry, It's an exponential growth if the base number is larger than 1. It's a decay, or the exponential relation is decreasing when the base number, it shouldn't say smaller than 1. It should say between 0 and 1. So between 0 and 1. Meaning if it's a fraction or decimal. Steepness depends on the larger the base, the steeper the relation, increasing, and then decreasing. The smaller the base, the steeper the line. Here we have exponential relations. We have growth, final value equals initial value times growth factor to the exponent number of periods. Decay, same thing, except instead of growth factor, we have a decay factor, and then half-life is just the initial value times 1/2 or 0.5 to the exponent total time divided by half-life time. So all of this we went over in depth in the units. Once again, this is just a quick summary. So all of this, you have to go back to the unit video or lesson or notes and get a more in-depth explanation. Right now, I'm just doing a very quick summary. Oh, good job. The number of termites in a colony increases by 40% every month. There are 4,800 termites now. How many ants will there be 8 months from now? So I think they mean termites. Will there be 8 months from now? Well, right now, we know the answer is always A is equal to P times your growth factor to the power of, time. We know our growth factor is 40%. Now, how do we do 40%? We'll convert it into a percent. Sorry, convert it into a decimal. So 0.4, and then you add 1 to it. So 1.4 is my growth factor. And then my time is 8 months. My initial value is 4,800. So this is my equation. 4,800 times 1.4 to the power of 8. Plug it into your calculator there. You should get, let me see, 70,838 roughly. Just rounding up. Approximately these many ants, or termites, sorry. That's it. Example 10. Let's see. The half-life of a radioactive substance is 16 days. How much of 120 grams sample will remain after 64 days? Well, we know that this is half-life. So my growth factor or decay factor is 1/2. We know that. The initial value is 120 grams. So we know the initial value is 120. And what is the exponent going to be? Well, we know it's 64 days, but we know the time for half-life is 16. So we need to do is 64 divided by 16. So that becomes 120 times 1/2 to the power of, now 64 divided by 16, that's just 4. So 1/2 to the power of 4, and then times 120. That's it. That's how easy this is. You get 7.5. That is the answer. That's how much will remain, 7.4 grams of the radioactive material after 64 days. All right, we have personal finance, we got interest, I equals PRT, simple interest. Interest is equal to the principal, the initial amount, times your interest rate, expressed as a decimal, and then time expressed in years. Important stuff there. Always have to understand that for simple interest, time is in years. So we got I is equal to PRT. Principal is 880. That's the initial amount. R, the rate is 4.8%. So that's going to be 0.048. Very important to understand how to go from a percent to a decimal. Just divide by 100. And we know that this is 18 months, but we don't write 18 here. This is important. Students always make this mistake. You're supposed to do 18 months. There's 12 months in a year. Divide by 12. Get 1.5. So you have to write it in terms of years. And that's the answer. So 880 times 0.048 times 1.5, which is 63 point, what was that? $36. So $63.36. That's how much interest is going to be made if you invest at those points. Now, compound interest, this is the equation here for compound interest. And this is the last example for today. We just made it. How much would a $3,000 investment how much would a 3K investment be worth after 4 years if it earns 8% per annum compounded monthly? This is important. So our initial amount is 3,000. 3,000. Our 1 plus I. The I is 8%, but it's not actually 8%. It's 0.08. But it's not actually 0.08. It's 0.08 divided by 12 because it's compounded monthly. My exponent is 4 years, but it's not exactly 4 years because 4 years times 12 because we're dealing in monthly. So that 12 is that key number there. So let's do this. 0.08 divided by 12 plus 1 is going to be 1.0066666. So I'm just not going to write it all, but I'm going to keep these values in my calculator so I don't round. And 4 times 12 is 48. So now we take this number in the bracket, take it to the power of 48, and then times it by 3,000. And we get a number of $4,126.99. I'm just going to round that up because it rounds up. That's the answer. All right, that was a summary of everything that we have learned, or as much, well, not everything, but that was a summary. Work today, finish that final. Oh, no, this is wrong. Sorry. It's the culminating. It's the culminating because this was supposed to be due yesterday, this lesson. So you have your exam. Will not be accepted after 11 a.m. Tomorrow. You have all day today to do it. So it's 9 a.m. Okay, this is a little bit older. You have to update the things a little bit more. So yeah, so go ahead and do the culminating today. Good job. Good luck. And yeah, that's